All right, so you're titling your notes. Okay, so here's a picture of some people skydiving, and the reason I had this picture is I kind of wanted to show, so their arms are all connected, right, to make this circle pretend it's circular. And what we're going to study first today is we're going to study arc length. So we're going to study, okay, how long is his arm span when it's curved? I mean, it's the same as when it's straight. It doesn't change the length of your arms. But anyways, so we're going to investigate how to find the length of not a segment, but the length of an arc. So in this picture, if all those people were the same, had the same, arm span, right, we could find the circumference of this circle, and we could divide it by 1, 2, 3, 4, 5, 6, 7. We could divide it by 7. We're going to kind of use that reasoning when we're trying to find the length of an arc. We're going to use some proportional reasoning. Let's just say that. Okay, arc length is represented by a lowercase, cursive, italicized L. Once again, it's so weird. So we're using the same variable that we used for, do you remember? Slant height, and now it means arc length. They're not related, they're just the same variable. So we use a cursive lowercase l to represent arc length. The way that we're going to find the length of an arc is we're going to use a proportion, right? So if I asked you, what is the distance from A to B along the curve? Could you measure it with a ruler? No. Could you measure it with a formula from your formula chart? No. Okay. So we do agree, Aaliyah's given in a way, but we do agree that the amount that the angle opens affects how long the arc is, right? Right now you can't find the length of AB unless you've already studied this. But right now, could you find the length of the full circle? Could you find the length, the distance all the way around? Yeah, you could, right? You know that it's 2 pi r. It's the circumference. So I'm not going to ask you to find the circumference. I'm going to ask you to find a portion of the circumference. And all you need to figure out is how much of the circumference you need. Do I need half of it, a fourth of it, a third of it, 5/8 of it? How much of the circumference do I need? And how much is going to depend on how much that angle is opening. The more I open the angle, the further the distance from my fingertips become. We're going to dive right into the formula instead of discovering it today because of time. Please write this proportion in your notes. L over C equals M over 360, where L stands for the arc length. C stands for the circumference of the circle. M stands for the degree measure, like if this was 40 degrees. And 360 is, of course, the number of degrees in a circle. So I kind of want to show you how this works, and I want you to understand that this proportion, you do have to memorize it, by the way. You do have to memorize it. But it's really just a part over whole equals part over whole. Let me show you what I mean. The arc length is this. So arc length, that's a part over all the way around. Part over whole. Well, we go over here and you can measure a circle in degrees, right? 360. But you can also, that's the measure of it, but you can also find the length. And so we're going to do part over whole again, but this time we're going to do it with degrees, not with how long it is, but the degree measure. And so 40 would be the part that we want, and 360 would be the degrees all the way around, the whole. So this proportion is just part over whole equals part over whole. So that's kind of can help you memorize that formula. Okay, let's try some. Go ahead and try this one on your own. Find the length of arc AB. How long is arc AB? So we're going to dive right into our new proportion that we're going to memorize, right? L over C equals M over 360. Where did I get 24 pi? Circumference, right? 2 pi r. So the circumference is 2 times 12 times pi. What are we going to do to solve for our variable? What do you do when you have a proportion and you're missing a piece? You cross multiply, right? Are we going to press the pi button? No, because we love to be exact. Okay, someone's mentioning that we could reduce. Of course you could reduce, but when you cross multiply, your calculator reduces automatically for you, so reducing it would be an extra step and it's not really necessary. 30 times 24 divided by 360. Now, if you were asked to do this by hand and you weren't allowed to use a calculator, reducing would be a very good strategy. Yes, definitely. Make sure after you cross multiply that you multiply back in that pi. No pi in your answer, no credit at all. The length of that arc is not 2. The length of that arc is 2 pi. Oh, it's for meters. That's the units. I always try to put my units. I try to be really thorough. It's important to be thorough. Okay, so 2 pi. All right, try this one. I'm going to go ahead and dive right in again because that time is ticking. L is given over C, 2 times 6, equals, I don't know, M over 360. Notice what happens to our pi's. Of course, our pi's are going to cancel because our answer's not going to have pi in it. Angle measures don't have, well, wait till we get to radians, but degree measures don't have pi in it. So we're going to cancel those pi's out. We don't need to worry about pi. 3 times 360 divided by 12. So that was a 90-degree angle all along. Did you know it? Okay, one more of these simple ones. L over, I don't know C because I don't know R. Can't get a C without an R. L over C equals M over 360. No need to reduce. We are going to cross multiply right away. 2.5 times 360 divided by 150. I have now found C. I haven't found R yet. Our circumference is 6 pi. It needs to have a pi in it because no pi got canceled yet. How do you go backwards from circumference to radius? Divide by 2, right? Technically, you're dividing by 2 pi. So cancel those pi's out, divide by 2. The radius of this circle is 3 centimeters. Now, some people will forget to get rid of the pi, and they'll put 3 pi. Here's my clue to you to know whether to put pi or not. If your answer's curved, you have a pi in it. If your answer's a segment, if it's straight, no pi. A radius is a segment. It is a straight segment, line segment. Therefore, there should be no pi in your answer. So don't get pi happy and just start putting pi all over the place. Okay, we are going to skip this one. This is going to be our last one, and then we'll do area of a sector. The minute hand of Boston's Custom House Tower is 13 feet long. That's a huge clock. That's like double a really tall person. And that's how long the minute hand is. Whoa. In 5 minutes, how far does the tip of the minute hand travel? In 5 minutes, how far does the tip of the minute hand travel? So we're going from the 4, that was my alignment's off. We're going from the 4, and we're traveling to the 5. We're trying to find L. We're trying to find the arc length. And my mouse is sitting right there. From the 4 to the 5. So we're trying to find the length of this little bitty piece. We're trying to find that L right there. This is the 4, this is the 5. Let's start with our proportion. Let's just see what we already have. Let's see if we have enough to go straight to our proportion. L over C. Okay, well I know L. 13. What does that represent? What variable is that? 13 is the radius. Okay, so 2 pi r. L over C equals M. Ooh, what's the angle measure? So a full circle is 360 degrees, but we've divided it into 12 equal parts. Good. So if we do 360 divided by 12, we know that from here to here, from the 4 to the 5, it's 30. And now we are in business. 26 times 30 divided by 360, and we get an ugly repeating decimal. This is when we do math, enter, enter. Okay, I'll tell you in a second. Now, that answer is perfect. It is exactly accurate, but it's not very real world. So I do recommend that you multiply that by pi, and let's also get a real world answer. So in the real world, it travels about 6.8 feet, and that makes much more sense to us than 13/6 pi, right? What's really important as we move forward is to know that an arc has both a length, but it also has a measure. It's two different characteristics of an arc. For example, you as a human, you have a height and you have a weight. Your weight doesn't say everything about you, and your height doesn't say everything about you. Same thing, the length of AB, the length is 4 pi. But the measure, the degree measure, is 160. 160. Okay? So arcs have a length, but they also have a measure. It's like having a height and a weight. It is also important to know that the measure of a central angle, is equal to the measure of its arc. That's not the length. The length of BC is not 82 degrees, but it's pretty simple. If the angle opens up 82 degrees, then the arc opens up 82 degrees. So central angles and the arc that they open up to, totally equal. Okay, I'll let you write that sentence real quick, and then we need to get moving. Okay, so now part 2 of the lesson. So we talked about how long an arc is, how to find the length of a curve, really, is what we found out. Now we're going to find the area of a sector. A sector is not a triangle. It has 2 sides that are segments, and then the other part is curved. So we're going to figure out how to find the area of a portion of a circle. The variable that we used for arc length was L. The variable we're going to use for area of a sector is ASEC, capital A, subscript SEC. All right, capital A, subscript SEC. Southeastern Conference? Anyways, okay, so we're going to take the proportion that we used for arc length, and we're just going to tweak it. We're going to use the same proportion, but we are going to go from 1D, from a length, to 2D. What do you want to change? Go ahead and go, yeah. Instead of L, we're not going to be looking for L anymore. We're going to be looking for ASEC. Is the circumference going to do us any good for ASEC? No, this time we're gonna upgrade. We're gonna upgrade to area. So it's the same exact proportion, except the L and the C got replaced with ASEC and A. Go ahead and write this proportion down, please. A stands for area of a circle, so it's pi r squared. M is still the measure, the degree measure of the angle, or the arc. So same exact thing, but now we're in 2D instead of 1D. Now we're shading it in instead of finding the length. All right, let's try some. All right, let's use our new formula. Area of the sector over area of the circle. So we're not doubling the radius now, we're squaring it. ASEC over A equals nothing changed here. Cool. So when you're memorizing these formulas, they're going to be very easy to memorize because they are almost identical. We do our good old cross multiplying. We do not press the pi button. And we get 27. And if we don't put the pi on our answer, we get it wrong. So the area of the sector is 27 pi inches squared. 27 pi inches squared. It's kind of weird, but that's the area of this. the answer has a pi in it because the shape that we're finding the area of has a curve in it. When you have curves, you have pi. All right, next one. Same thing, same proportion. We're going to be working backwards a little bit. The area of the sector is 4 pi, so that's, we put that where the A sec goes. Area of the circle, ooh, we don't know R. Without an R, we can't have an A. So we're going to put A, and then the M, and then 360 is a constant. That never, ever, ever changes. Okay, cross multiplying gives us 4 times 360 divided by 160. And we get 9 pi. And we know to go backwards from circumference, we divide by 2. To go backwards from area, we square root, right? Okay, so the opposite of pi r squared is you get rid of the pi and you square root. So the square root of 9 is 3. So if you're in circumference, you're dividing by 2. That's the opposite of multiplying by 2. If you're in area, you're square rooting. Find the radius.